Jai Hind students, welcome to my YouTube channel. Students, never ever give up. You have the full ability to do any work perfectly. So keep working hard and follow your dreams. Actually, you are the person who is responsible for your own happiness. We can only show the path, but you have to make it. We as a teacher can only act as a guide, as a philosopher to show you the correct path. But it's you who need to follow that path. So think about your life carefully and wisely, and I know you can do very, very well in your life. Right, students? So with that optimism, let's start this particular session. In this particular lecture, we'll be discussing again some numericals based on free body diagram and constructing equations with the help of those free body diagrams. Right? So initially, we'll start with these four questions. Let's try to attempt the first question. This is a question, students, where the pulleys are considered to be massless and frictionless, and the strings, they are considered to be massless as well as inextensible. So in this question, we are supposed to find tension T1, T2 in these two strings and the acceleration, right? The strings are inextensible. So as a result, we are aware for a given time, we are aware that acceleration is directly proportional to displacement, isn't it? So, if this body moves down by 10 centimeter, this body will move along horizontal towards right again by 10 centimeter, and this body will also move upward through 10 centimeter. So, all the three bodies in a given time will cover the same displacement. So, therefore, acceleration being proportional to displacement for a given time for all the three bodies would be same, right? So if this body is assumed to have acceleration A, then this body will also have acceleration A, and this body will also have acceleration A, and in the upward direction this body, right? So this is the tension T2 over here. Tension is a force which always acts along the length of the string towards the point of suspension. Here the pulleys are massless, so no need to represent any force acting on the pulleys, right? So here the tension is T1, so this is T1, this is T1. Tension, it always acts along the length of the string towards the point of suspension, right? So let's try to construct the equations then. Okay, for 1 kg mass, right? So over here, this is 1 kg. So weight would be 1g. Tension is T1 and it is getting accelerated in the upward direction. So students, what is the net force acting over here? It will be T1 minus g. And net force acting on a body, it's given by mass into acceleration. The mass of this body is 1 kg. So it will be 1 into A. So this is the first equation, students. Right? So now consider free body diagram for mass of 6 kg. Let's consider the free body diagram for mass 6 kg. So this is 6 kg mass. So its weight will act in the downward direction, 6g. Reaction, it always acts perpendicular to the surface over which the body is placed, isn't it? Over here the tension is T2 and towards left the tension is T1. Acceleration is along this direction. Now look, students. This body of mass 6 kg is getting accelerated along this direction. So net force will be along this direction only. The body is not having any motion in the vertical direction. So along the vertical direction it is under balanced forces. So R must be balancing 6g. And T2 must be greater than T1 because the body is being getting accelerated towards right, isn't it? Towards the acceleration. So T2 being greater. So the net force acting on this body is T2 minus T1. The net force is equal to mass into acceleration. The mass of this body is 6. So it will be 6, acceleration is E. So put this as equation number 2. Clear, students? Okay. Now, third one. Let's draw the free body diagram for mass of 3 kg. So, for that, what we get is, this is the body of mass 3 kg, right? force, that is weight 3G will act in the vertically downward direction, tension T2 acting in the upward direction, and its acceleration is in the downward direction. So here the net force is 3G minus T2. This is the net force acting on this body. And net force is equal to mass into acceleration. The mass of this body is 3. So it will be 3 multiplied by A. So students, these are the three equations which we are supposed to make use of in order to find out the value of T1, T2 and A. Now what you do is, if you add these three, so let us add all the three, adding 1, 2 and 3. What we get is, left hand side, T1 minus G plus T2 minus T1 over here plus 3G minus T2. And right hand side, it is 1A, over here it's 6A plus 3A. So what we get is T1 minus T1 get cancelled, plus T2 minus T2 get cancelled. So 3G minus G is 2G, and it is equal to 6, 7, 8, 9, 10A. Right? The value of G here is to be considered as 10. So what we get is 10A is equal to 20. Therefore, A is equal to 2 meter per second square. So this is the answer of the first part. That is, the acceleration of each of these three bodies constituting the system is 2 meter per second square. Right? Now let's find out the value of T1 and T2. We can substitute this value of A over here and get the answer for T1. Right? So T1 would be, students, A plus G. Isn't it? A is found to be 2. G is considered to be 10. So T1 is 12 Newton. This is the answer of T1. Similarly, T2. It can be obtained by using this relation, isn't it? Or this, either of these two. So let's substitute the value of T2 over here. So what we get is, okay, let's substitute the value of A over here. So A is 2. So we get G is 10. So 30 minus so 30 minus T2 is equal to A is 2. So it will be 6. So what we get is T2, it will be equal to 30 minus 6. That is 24 Newton. So students, T1 is 12 Newton, T2 is 24 Newton, and the acceleration of each of these three bodies is obtained to be 2 meter per second square. So this is how this question can be easily solved. Right? I hope you have understood the concept involved. You need to draw the free body diagram, and then you need to construct the appropriate equations. You can do it directly without drawing the free body diagram as well. You can do it directly without drawing the free body diagram. Right? Okay. Let's consider question number B then. In question number B, we are supposed to find out the ratio of T1 and T2. And the strings are massless and surfaces in contact are frictionless. It is given. So the strings are inextensible and massless, and obviously force of friction is considered to be negligible. We are supposed to find, in question number B, we are supposed to find T1 divided by T2. This is to be obtained. Clear, students? So first step is to draw the free body diagram, but you can make use of your common sense as well. Let's make use of some shortcut method, right? What we can do is, since this string is massless, so the same situation can be redrawn like this. 3 kg and 12 kg, it will add up to 15 kg, right? And this is also 15 kg. And here the force is at F, and this is angle of 30 degree. And here the tension is T1. This is T1, right? So this diagram, these two bodies can be combined together so as to form a single body of mass 15 kg. Let's find out the value of T1 first. right? So what you do is, since the strings are inextensible, so acceleration of all the bodies must be constant. It must be same, isn't it? Acceleration must be same. So if you draw the equation for this particular body, or free body diagram, so what you get is, this is 15g, this is the normal reaction, this is T1, and this is the acceleration, right? If a body is placed on a horizontal surface and the body is accelerating horizontally, then there won't be any net force acting in the vertical direction, isn't it? So R and mg, 15 mg are balanced forces. And net force acting on it is T1. So net force acting is equal to mass into acceleration. Mass of this system is 15 multiplied by A. Put this as equation number 1. Clear, students? Now consider this one, 3 kg. For 3 kg mass, what to do is, this is 3 kg. What are the forces acting over here? It is T2, isn't it? So the force acting over here is T2. It is having an acceleration of A, and obviously its weight will get balanced by the reaction, it is R dash. So the only force, net force acting on this mass of 3 kg is T2. And as per Newton's second law, students, net force is equal to mass into acceleration. Its mass is 3 and acceleration is A. So we need to find out the ratio of T1 by T2. So dividing these two, T1 by T2, we get 15A divided by 3A. So it will be equal to 5:1. So very simple. So you need not to resolve this F into components and so on. You need not to draw the free diagram for all the 3 bodies. Instead, you can consider these 2 bodies as a whole, as a single body, and then you can obtain the expression for T1, and then consider the equation for 3 kg mass. That will give you the expression for T2. Dividing these two will give you the ratio of T1 and T2. So the answer is 5:1. Right? Okay, third question, students. Calculate T1 and T2. T1 and T2 are the tensions. When whole system is going upwards with acceleration of 2 meters per second square, right? This is fixed, and the entire system is being accelerated in the upward direction. The entire system is being accelerated in the upward direction. It's an interesting question, but again, you need not to construct the free body diagram and write the equations separately for the individual bodies. Instead, what we can do is, let's consider these 2 bodies to be represented by a single body of mass 8 kg. It is because to it, this string is massless, so it is not having any mass. So the net mass of this system, this one, it will be equal to 8 kg. So the diagram can be redrawn like this. It can be considered to be 8 kg, right? And here the tension is T1. This is given to be T1. So what are the forces acting over here? Its weight would be 8 into G, right? And it is being accelerated in the upward direction like this. It is getting accelerated in the upward direction. So now we can easily consider the equation T1 being greater than 8G. The equation would be net force T1 minus 8G is equal to mass into acceleration 8 into 8. Correct? So T1, it will be equal to 8 A plus G. So T1, it will be equal to 8. Acceleration, it's given to be 2 meters per second square. G, it is to be considered as 9.8. So what you get is T1 is equal to 8 multiplied by 11.8. So that will give us 94.4 Newton. So students, this is the value of the tension T1, right? Now, in order to find out the value of tension T2, we will consider this one, this one. So what we'll do is, for body of mass 3 kg. Okay, this is 3 kg. So its weight would be 3g. Tension acting upwards, it is T2. This is T2, and it is getting accelerated in the upward direction. Right? A, it's given to be 2 meter per second square. Right? So it is getting accelerated upward direction. So the upward force T2 must be dominating one. It must be greater than 3g. Therefore, net force acting on this body is T2 minus 3g. This is the net force acting on this body. And net force is equal to mass into acceleration. So mass is 3 and acceleration is a. So let's find out the value. T2 would be equal to 3a plus g. You could have done it directly as well, because in the previous theoretical article we have discussed, when a system gets accelerated in the upward direction, then the net acceleration of the system is a plus g. And if it is accelerating downward, then the net acceleration of the system is g minus a. Right? So you could have done it directly as well. Anyway, let's substitute the value over here. 2 plus 9.8. So it would be equal to 3 multiplied by 11.8. So that will give us 35.4 Newton. Right, students? So T1 is 94.4 Newton while T2 is 35.4 Newton. So that is how this question can be easily solved. Right? Okay. Let's proceed to question number D then. This is also a very simple question. Question D. Find the mass of block B. Its mass is to be determined, right? Its mass, it is to be determined. If the system is at equilibrium and we are supposed to consider the value of small g as 10 meter per second square. Okay, let's try to attempt this question. The system is at equilibrium means equal balance of forces. So the net force acting at any point on the bodies constituting the system must be 0. The net force acting at point A is 0. The net force acting at point B or body B is also 0. It is then that the bodies of the system is said to be at equilibrium. So for equilibrium condition, either the bodies must be at rest or they must be moving with uniform velocity. Right? So anyway, let's proceed with this question. So let's draw the diagram for body A. For body A. This is it. This is body A. So what are the forces acting on it? One is its weight. It is 10 into g. Mass is 10. So weight would be 10 into g. Reaction. It always acts perpendicular to the surface over which the body is placed. So this is the reaction force. Right? And this is the tension. Right? This is the tension. Tension, as I told you, it's a force which always acts along the length of the string towards the point of suspension. Right? So these are the forces. This is T. This is tension T. So here Tg can be resolved into two perpendicular components. One is in a direction opposite to the reaction. Right? And this angle we have discussed, students, it will be equal to 30 degree. Isn't it? So it will be 10 G cos 30 degree. While the other perpendicular component, this one, this is the perpendicular component. It would be 10 G sin 30 degree. Clear, students? So this is the weight, this is the reaction, this is the tension. So weight needs to be resolved into two perpendicular components. And already in the previous lecture we have derived it mathematically that this angle would be equal to this angle. We have proved it, isn't it? Let me prove it again for you, like this. This is angle theta. So what you do is, at this point, if you draw a vertical and a horizontal line, so obviously this angle would be equal to this angle. These two being parallel lines, it will act as a transversal. So these two will be the pair of corresponding angles. Now what you do is, draw a perpendicular to the inclined plane, like this. This is perpendicular to the inclined plane. So this being theta, this remaining angle would be 90 minus theta. And the angle between vertical and the horizontal line is 90 degree. So this being 90 minus theta, this remaining angle would be also theta. So that is how it can be easily verified. This is what I've done over here, right? Okay. So let's construct the equation then. The body is at equilibrium. So what it means is this reaction should get balanced by 10g cos 30, isn't it? And T, this tension, it should get balanced by 10g sin 30. Equilibrium means the body is under the influence of balanced forces. No net force must be acting on the body. It is possible only when R is nullified by 10g cos 30 and T tension is nullified by 10g sin 30. Clear, students? So put this as equation number 1. Let's consider body B. For body B. Okay. Let's draw the free body diagram for this. Its mass is suppose m, so its weight would be mg. Tension would be along this direction. So acceleration is 0. It is in equilibrium, so no net force is acting, so acceleration is 0. Acceleration 0 means net force is 0. Therefore, T must be equal to mg, isn't it? Or T minus mg is equal to m into a is 0. So T minus mg is 0 or T equals to mg, you will get this. Now make use of these two. From 1 and 2, we get, substitute this value of T as mg over here. So we get mg is equal to 10g sin 30. So g get cancelled. So m would be equal to 10. Sin 30 is half. So it will be equal to 5 kg. So student, in the last question, the mass of block B must be 5 kg for the bodies to be at equilibrium. Right? So students, I sincerely hope you have enjoyed this session, and please, as I have told you time and again, physics without numericals is incomplete. Right? Once you are thorough with your theoretical knowledge, you need to concentrate on numericals. It is only after doing numericals, then only you can gain in that confidence. So do practice as many numericals as possible. So students, that's it for this particular session. Next session, I will come up with some more numericals. Right? Till then, goodbye and do take very good care of yourself. Thank you.